Hi everyone, I'm Ashima and I'm an intern in the REACH team. And congratulations for making it into the knockout round in FIFA. So today I'm going to be giving you a basic introduction to Docker, what it is, why you would want to use it, and how to use it. So until I got down to making these slides, I hadn't really thought of defining Docker. And once I did, these are the questions that popped into my mind. So as any good programmer would do, I read a lot of blogs. And after doing that, I realized what Docker is not. So Docker is not just a container technology. Under the hood, it does use containers to provision applications, but that doesn't limit it to being just a container management tool. It's not even a configuration manager replacement. In fact, it works very well alongside other provisioning tools like Chef and Puppet, etc. Docker can be used as a platform as a service. In fact, it is very similar to Heroku. Just like Heroku has dynos, Docker has containers. Heroku has a build pack. Docker has Docker files. Heroku has slugs. I don't know why they kept that name. And Docker has images. But the thing is that this is just one of the uses of Docker, and it doesn't really define what Docker is. So after all that, I realized that the definition that most accurately describes Docker is the one on the main website. So Docker is an open platform for developers and sysadmins to build, ship, and run distributed applications. Now, Solomon Hykes, the founder and CTO of Docker, describes this as a response to the new distributed nature of software development and delivery. The next two slides are taken from his presentation. So once upon a time, this was the nature of software development and delivery. There was a single framework on the software side, which would run on a single server on the hardware side. Now it looks something more like this. So the software stack is much more distributed, and it is composed of many loosely coupled components written in different languages, running in different frameworks that may change over time. This software stack has to run on a wide variety of hardware, like your laptop, your colleague's laptop, the testing server or cluster, and even the public cloud. So a situation that may arise is that the code that works on my machine doesn't work in production. That may be because I'm using Python 3.0, but the production machines still use Python 2.7. Or I'm running Ubuntu and I have some version of a library installed on my machine, and the production servers are using Fedora. So Docker gives you the benefit and the guarantee of consistent environments across all machines. Now to conclude the argument for Docker, I would like to highlight some main features that I consider important. And a disclaimer here, most of the arguments are shamelessly plagiarized from a Stack Overflow answer and from the Docker main website. So the most important benefit of Docker is portable deployment. So the thing is that developers using Docker can build any app using any language and in any tool chain. And sysadmins can abstract away all the differences between operating system distributions and the underlying infrastructure. Dockerized apps are completely portable. They can run on any system that has the Docker engine installed. So you can run it on your laptop or your colleague's OS X or Windows in the future, and on the QA server that's running Ubuntu, or on the production data center VMs that run Red Hat. The second feature here is Docker is lightweight and fast. So because Docker leverages the existing kernel image of the underlying hardware, it doesn't put any extra load, at least a very little extra load on the server. And unlike a traditional VM, it has very little overhead. Sharing. So Docker comes with a public registry on index.docker.io where thousands of people share many useful containers, and you can find almost any useful container over there, from Redis to CouchDB, Hadoop, base images of various distros, etc. Also, the Docker team itself manages a set of standard libraries of the most popularly used distributions like Ubuntu or Fedora. One more thing is that the Docker registry itself is open source, so you could deploy one of your own for internal sharing purposes. Finally, Docker uses a union file system that is a layered file system, which helps it to promote component reuse. That is, if you have an image, you can use it as a base for your future work and build more specialized components out of that. For example, if you build an image with your ideal Python environment, you can use it for as the base for all the 10 of your web services. Now that I have successfully convinced you to use Docker, you may want to know how to use it. So this is time for some terminology. Images in Docker are read-only templates, and you can say that it's the operating system minus the kernel. But an example would be an Ubuntu operating system with Apache and your web application installed on it. So in Docker, images are used to make containers. So containers are made from images, and they contain all the files necessary to run applications. And each container, as is stated there, is an isolated and secure, in quotes, because I don't know how secure anything they claim to be secure can be, secure application platform. Finally, registries are public or private stores from which you can share your Docker images. So the Docker architecture is a client-server architecture. You have two components. That's the Docker client, which runs on your machine, and the Docker daemon that may run on the same machine or on a remote machine. So the Docker daemon is the one that does all the work of building, running, and maintaining the containers, and the Docker client is what the users use to talk to the daemon. And the Docker, obviously you can pull and push images to the Docker registry. Now I'm going to run through some of the basic commands in Docker as hands-on. Hopefully this works. So this is the daemon running on my machine, the top one. Sorry, clicking the wrong button. This one. And so that's the Docker client, and this will give you a list of helpful commands that are used with the client. Now I'm going to search for an image on the Docker public index. Let's see. This may take some time. Okay, sorry. Cool. There are a lot of them. I'm not going to choose from one of them. I'm just going to download the standard one. So as you see, it's pulling FS layers. That's it's using the union file system. Each layer is independent, and that's the philo. Sorry. Can you hear me now?
Yeah.
Okay. I should have done that before.
This might be a little more annoying, but I think you're going to have a better time.
Yeah, thank you. Okay, so it pulled in the file system layers. Layering is the basic core philosophy of Docker. Everything is a layer. So now we have our first image. actually downloaded more than one of them. Oh yeah, I had this before. So this is the base image that we downloaded, and we're going to make our first container. Can you guess the application that I'm going to run in it?
Reach.
I know. That's too tough for me. I mean, what do you do first when you learn a new programming language?
Hello world.
Yes. Thank you. Though it's not an application, but yay. The container is closely tied to the application, and when the application exits, the container also dies. Now I'm going to get inside the container by running it in the interactive mode.
Need the 12 dot.
Sorry, sorry.
12 dot.
So I'm inside the container, and I'll prove this to you. So this is the operating system in the container, and this is my operating system. Okay. And this is the kernel which the container will also use, because all Docker containers share the base kernel image. So, yes, it's the same. Now, you saw that it takes like a couple of seconds to start a container, and I don't think you can do that with a virtual machine. And you can also start many containers. So we have one more. So I have 3 containers running on my system now. And the system doesn't seem to be too bothered about that. This is a problem with Docker, that you have to type sudo for everything.
You can actually add your user to a Docker group, and you don't get asked for sudo every time.
Okay.
Whether or not that's secure is another question that I would defer to.
So these are the 3 containers that my system is running, and I'm going to modify the first one.
Where do those names for the containers?
Yeah, just make it look.
Yeah.
Okay.
Or like the Docker daemon is right.
So Docker has the concept of a commit. So I made a change to the container, and I can commit it so that it's persistent. Oh, sorry, not. So now I have a new image, Ubuntu with Vim, and I can use this as a base image for any project of mine. The last thing I'll show you with Docker is creating a custom image using a Docker file. So I have a Node.js application here. These are its dependencies, and this is the application. It's just going to reply with hello world again. So this is the Docker file that I'm going to use to build an image that contains this Node.js application. And the first line is always the base image. Here it's CentOS 6.4. All these commands that are prefixed with run are going to run inside the container. This is just installing some packages, and add copies files from the host to the container, because the Docker daemon may be running on a remote host, so it needs the files to actually run the application. And I'm exposing this port. This is the one that is used to connect to the application. And finally, this is just an extra port. This is the application that the container will run. So if you notice these hashes, they're actually intermediate images. Again, there are layers. So the first time it runs, it's going to perform all the actions, but if you do it a second time, it's just going to use those layers that they are already built.
There are certain things you can do to invalidate the cache. One of those is doing apt-get. So if you invalidate the cache, then you can see this lock.
I thought about whether to make you guys wait and look at these logs or not. And then I thought it would be better for you to see the difference between it performing all the operations and it using the cache. Okay, so if I try to run it again, it just uses the cache. And if I modify one of the instructions like I had before, I added an instruction, so all the instructions before this instruction will use the cache. So it's only installing the npm packages. Now we have the image, and I'll just show you the image. This is the image that we created, and I'm going to use it to run our Node.js container. This is the port that the Node.js container will run on externally. Okay. And the application is working along with the port forwarding and everything. So you have a Node.js application inside a container, and you don't have to worry about it because it's all sandboxed. Finally, I would just like to share some of the real-world uses of Docker. So Mailgun at Rackspace uses Docker to maintain a uniform development environment across all dev, QA, and prod. They also have built their own orchestration library around Docker called Shipper, and it handles basic tasks like starting and stopping groups of containers, and making sure a particular container is running, restarting a container if it stops, and so on. Spotify has more than 60 web services, and each service is deployed on a different physical machine around the world. So with this infrastructure, they realized that hardware provisioning was very slow, and their hardware utilization was low because each service was on a different machine. Also, the nodes would get into inconsistent states when the developers modified them. So this was an ideal candidate for Docker usage. Commodit is a company that provides IT automation as a service, and they use Docker to deploy hundreds of machines, each with custom configurations, and test how their platform reacts to these kind of loads. It's easy to see how Docker can be used to provide sandboxed environments for students to play with in the labs. And Docu is Docker-powered Heroku, and it's written in just over 100 lines of Bash. So they call it the Heroku killer. And it's open source, so you don't have to pay for it. Anyway, so thanks for listening. I hope you liked the talk, and consider doing something with Docker for the hackathon tomorrow. And now Dave will be happy to answer any of your questions.
Go to you first. When's Docker coming to Windows?
So can container talk to each other?
Sorry, what?
Like, application running within the containers, can they talk to each other, or do they have to build those?
Yes, they can talk to each other. It's you just have to expose the ports, and it's just like a normal application. Yes.
Is it normal to do everything as root in a container, or what's
Yeah, I think that's the default, but there must be a way to not do it as root. I'm not sure. Yes.
So if you're inside a container, you can see the kernel that's running, is that correct?
Yes, I
Okay.
think so.
I'm just wondering how they're coupled, because I've run into situations where changing a kernel version, broke a package, or fixed a package, just visualize running that inside a container, and how you, maybe it doesn't happen very often, but how you deal with that.
You're saying the containers are tightly coupled with the kernel?
Like, yeah, some of those packages will operate differently under one kernel.
Right, if you have 1204 packages and you're running them on Docker running on a 1404 system, how does it translate?
That's a good question.
Translate.
You do have to have a
Not
certain
sure.
kernel version. I don't know the answer to your question, but I do know that you have to have a advanced enough Linux kernel. I think that's because of LXC bugs, not because of any packages in the.
Is that actually part of the image? Does it know what kernel is?
I'm sorry, what?
Like in the image, the Docker image?
The Docker image doesn't contain the kernel. The kernel is shared between all the containers on a machine.
But when you commit to a kernel, you commit to an image, does it know what kernel it ran on?
I don't think so.
Okay.
Kernel is independent of, so you build an image on your machine and you deploy it to the daemon. So the daemon has to, it depends on the kernel running in the daemon, on the remote machine. Well, thank you guys for being here.